Welcome to the Explainer. So, if you're gearing up for the Nancy Grace Roman Space Telescope's upcoming Cycle 1 observations, you know that preparation is literally everything. Today, we're bringing you a highly focused technical tutorial on a really vital piece of the observation planning puzzle. We're talking about the Roman Background Visualization Tool, or the RBVT. Look, if you're planning to observe incredibly faint targets, understanding how to navigate the near-infrared background isn't just a nice-to-have, it's absolutely crucial to your science.
Okay, let's dive into this. Here is our roadmap for mastering this tool today. We'll start with the Faint Source Challenge, introduce the RBVT, decompose the background, decode those Violin plot visuals, and finally, map out the path from the RBVT right into the ETC.
All right, Section 1, the Faint Source Science Challenge.
Now you might be wondering, why does the near-infrared background actually dictate your Roman survey schedule in the first place? Well, it's because space isn't perfectly dark. In the near-infrared, there's this persistent glow from various sources. And the catch is, this glow isn't static. It changes depending on where the telescope is pointing and what time of year it is. This is a big deal because background-limited observations pose a severe danger to the signal-to-noise ratio of your faint targets. Think about it. When the background is high, the noise it introduces can easily completely overwhelm the faint signal from the distant objects you're trying so hard to study. If you schedule your observation on the wrong day, you might just not get the data you need, honestly, no matter how long you expose the detector. Getting the background wrong is incredibly costly. And the stakes here? They're sky high. Excess background light can completely wash out your targets. Roman is designed to hunt for distant supernovae to measure dark energy. It's equipped with a technology demonstration coronagraph capable of imaging exoplanets that are 1 billion, yes, literally 1 billion times fainter than their host stars. It's looking for extremely faint, high-redshift galaxies from the early universe. If you don't account for background variations, you run the very real risk of wasting incredibly valuable Cycle 1 observing time on a day when the sky is just simply too bright.
Moving right along to Section 2, introducing the RBVT.
So what exactly is this thing? Well, the Roman Background Visualization Tool, or RBVT, is an interactive application running right inside a Jupyter notebook on the cloud-based Roman Research Nexus. It basically lets you explore the near-infrared sky background observed by Roman's wide-field instrument. It gives you the background as a function of your target's specific sky position, its RA and dec, as well as the day of the year and the wavelength. It is truly your crucial first step for assessing background levels.
Now, I want to draw a hard line here because it's super easy to get these two tools confused. On the left, we have the RBVT. It is purely a quick-look background assessment tool. That's it. It doesn't compute your signal-to-noise ratio, and it definitely doesn't include detector effects. Its one job is to help you find favorable calendar days. But on the right, we have the Roman ETC, the Exposure Time Calculator. That is your heavy-duty tool for detailed scene configuration, signal-to-noise calculations, and detector effect modeling. So the rule of thumb is, use the RBVT first to find the right date and the ETC second to figure out your exposure time.
Let's jump to Section 3, Decomposing the Sky Background.
Think of this process like carefully peeling back layers of the sky. To reveal those super faint targets beneath, the RBVT mathematically strips away different layers of emission because the total background is actually a composite. First, you've got zodiacal light, which is just dust in our own solar system reflecting sunlight. Then you have thermal emission. You also have the Interstellar Medium, or ISM, which is dust and gas within our own Milky Way. And finally, the cosmic infrared background, or CIB, which is the collective glow from unresolved galaxies all across the universe. The tool cleanly calculates the contribution of each of these to give you your total background.
Now, it's important to keep our boundaries in mind here. The underlying wavelength grid in the RBVT models the background specifically from roughly 0.5 to 2.5 micrometers. Furthermore, the tool computes the background level for a specific optical element using only that element's pivot wavelength. It basically assumes the background spectral shape stays approximately constant over that specific filter's range.
So the real trick is understanding how all these layers interact over time. And this brings us to a really quirky technical concept the developers call the bathtub parameters. Imagine a bathtub. For a given sky position and wavelength, the thermal, ISM, and CIB terms are essentially the fixed bottom of the tub. They remain totally constant across the year. However, the zodiacal light acts like the water sloshing around inside. It varies wildly based on Roman's viewing geometry as it orbits at the L2 Lagrange point. Because that zodiacal light sloshes around so much, your total background changes day by day.
Which brings us to Section 4, Visualization with Violin plots.
Now, what's really interesting about this is the exact math generating these plots. It happens in 3 steps. First, the tool collects the total background across all modeled days for your chosen filter's pivot wavelength. Second, it computes the quartiles, the minimum, medium, maximum, and 25th to 75th percentiles, all in linear space. Finally, to give you that really nice, smooth, violin-like silhouette, it builds the shape using a statistical technique called kernel density estimation, or KDE, in log space. Basically, it estimates the density of log10 background values and maps that to a symmetric half-width.
Let's quickly decode the visual anatomy of this plot so you know exactly how to read it to find your optimal windows. The width of the violin shape represents the relative density, so a wider section means the background sits at that specific level for more days of the year. The white box inside the violin spans the interquartile range, from the 25th to the 75th percentile. That dot right in the middle marks the median background value. And those thin lines stretching out at the ends, those are the whiskers, showing you the absolute minimum and maximum background levels for that filter throughout the entire year. By just glancing at where the fat part of the violin sits relative to the minimum whisker, you can instantly see if a target has a stable low background or a highly variable one. It's a real game changer.
Finally, Section 5, from RBVT to the ETC.
Let's see how this all builds into your actual workflow, because efficiency is definitely key here. Step 1, you run your target's coordinates through the RBVT on the Roman research nexus to identify those really favorable calendar days where the zodiacal light is low. Step 2, armed with that specific date, you move into the Roman ETC, specifically the Pandia Python engine, to run your full signal-to-noise and exposure time calculations, completely confident that your background level's optimized. Step 3, you take those finalized exposure times and plug them right into the AST Astronomer's proposal tool, or APT, to build out your actual observation visits. Honestly, sticking to this exact order saves you so much time and maximizes the signal-to-noise ratio for your Cycle 1 proposals.
Which leaves us with this final thought. Roman is going to have a field of view 100 times larger than Hubble's, and it's going to gather petabytes of data on everything from nearby exoplanets all the way to the edge of the observable universe. Your target is out there right now, hiding in that near-infrared glow. By using the Roman background visualization tool to strip away the zodiacal light and pinpoint your optimal observing window, the only question left is, what day of the year will you choose to reveal it? You can log on to the Roman Research Nexus to start exploring these tools right away. Thanks so much for learning with us today on The Explainer.